Alekier has launched several Haltemiar joystick kit for PS4, PS5, DSE, Xbox, and NS Pro controllers. What has Alekier done with the multitude of third-party controllers? Google Stadia, Hyperkin, Naken Revolution Unlimited Pro, GameSeer, and many more other brands and controllers. We released the Universal Haltemiar joystick mod kit for third-party controllers. The MCU on the FPCB performs the calibration. You can accurately reset the center step by step. Trim and customize the outer curve on individual poles. I'm demonstrating how to install Haltemiar stick and calibration FPCB on this Razer Rayu in this video. The replacement kit is flexible and widely compatible. The installation is complicated. I encourage you watching through the whole video. This is the circuit diagram of the Unia model. There are two options to install the calibration FPCB. On the PCB is to stack on the back of stick, while off the PCB is to house the FPCB somewhere else if there's interference in the structure. The green sensor takes VC power from the pin 3. This is likely to be different from the main PCB power supply, so I pre-isolate all 6 pins with blue tubes. The FPCB takes VC power from Y sensor, but it's uncertain which pad the VC comes from. It can be from the A or B. The signal goes from the middle pin 2 to XI and YI pads of FPCB. The MCU outputs the processed signal from XO and YO to the main board. The button signal is required during calibration. The signal can be from the near terminal H or for terminal U of the PCB. Take a close look on this demo board. On X sensor, only the pin 2 was insulated from the main PCB. The power pins are directly soldered because the power supply layout of main board is consistent with the joystick, while all the 3 pins are insulated on Y sensor because the power supply layout is opposite. The power comes from GND and V1 or V2. Short connect A and V1 if the A is the VC, or short connect B and V2 if the B is the VC. The sensor's signal inputs at XI, the processed signal outputs to main board at XO. The sensor's signal inputs at YI, the processed signal outputs to main board at YO. Short connect H and C1 if the button signal comes from near terminal H, or short connect U and C2 if the button signal comes from for terminal U. The onboard button K functions the same as the joystick button for entering the setting mode B. Short connect X or Y pads to reverse the direction of sensor's movement. Short connect the S pad to disable the setting modes. See what's in the box. 2 green Hall or TMR sticks. The 6 sensors pins are pre-insulated with blue tubes. 2 calibration FPCB. It can stack on back of Hall or TMR stick, or paste onto somewhere else and connect the power and signal with wires. The desoldering heating plate and some tools included in the box. Different joysticks come in different dimensions. This Universal Haltemiar repair kit works with sticks in Unia form factor alone. Unia is the type that was widely used in PS4, PS5, Xbox, and most third-party controllers. Uni B was used in some PDP, Power A, and some rare controllers. The X360 is much bigger. It was used in Xbox 360 and PS2. The Uni B's button sticks about 1.2 mm more than Unia does. We take away the biggest X360 and Uni-B, for they are not compatible with. This is the Hall or TMR stick in the box of Unia kit. Tear down the controller. Hold the PCB on the desk and take a piece of paper. Before desolder the old joystick off the PCB. The PCB should be carefully measured. Take a note on paper. On the right stick, the VC is on the pin 1 of X sensor. The VC is also on the pin 1 on the Y sensor. We're finding which solder pad the button signal comes from. Measure the volt of near terminal H and far terminal U when pressing the button repeatedly. I determined the near pad H is the signal pad because it shifts between around 0 volt and VC. I noted on paper. Then we measure the left stick. On the left stick, the main PCB powers the both sensors. On the pin 3, this is different from the right stick. Its button signal is at the near pad H. This is Hall or TMR stick with green sensor. All the 6 pins of the 2 sensors were pre-inserted with blue high temperature insulation tube. The sensor outputs the signal via the middle pin 2. This pin 2 must be isolated from the through via. The green sensor takes VC power at pin 3. On this right stick, all the 6 pins must be isolated from the PCB, because it is not aligned with the PCB power supply layout. The PCB power supply layout of the left stick is consistent with the joystick, so the blue insulating tubes of pin 1 and pin 3 can be removed. However, the tube on the middle pin 2 must be retained. I'm desoldering the right stick. Wrap the PCB edge. Insert the clamps. Do not knock off small parts. Hold the PCB on the desk. Screw the white tube onto the heating plate. There's no interference on the PCB. Use a big iron tip. Set the soldering station at a proper temperature. 320 to 350 is recommended. Resolder all the 14 soldering joints with low temp solder 6337 suggested. Make the joints a little bigger. Place the plate onto the Teflon pad. Apply some solder to heat it up. Move the hot plate onto the PCB. Lift the plate and place it on again for several times. The whole joystick gradually heats up. Move the hot plate around to make all 14 prongs well heated. You may need to add some more solder both onto the plate and joints. Try to pull off the joystick little by little. Finally, it came off smoothly. Apply some flux on the joints. Remove the solder with the red wire. You may need to add some solder. Twist the wire for more suction. Poke the via with the help of the Teflon wire. Clean the PCB with pure alcohol or PCB liquid. Check if the sensor's holes meet the 1.0 mm standard. This is vital, especially when you're installing a Lequier calibration FPCB with Hall sticks. It's ready for a new stick. I'm soldering the right stick. For easier viewing, rotated the joystick 180 degrees. This is the stick I prepared for the right. Check the blue tubes. Insert the stick and make sure it is aligned with the PCB. The blue tubes are intact. 6 pins of the sensor are isolated from the vias. First, solder the 4 biggest GND prongs diagonally, and then solder for button pins. Put on the calibration FPCB. Solder the GND pad first. Make sure the calibration FPCB is aligned with main PCB. Solder the B pad onto main PCB. This B pad is the VC. Short connect the B and V2 pad to power the calibration FPCB. Solder YO pad to the main PCB. Do not scratch the blue tube. Solder XO to the main PCB. Do not scratch the blue tube. Solder the red wire from pin 3 to V1 pad to power the Y sensor. Solder the red wire from pin 3 to V1 or V2 pad to power the X sensor. Solder 2 black wires from GND to the pin 1 of both X and Y sensors. Strip and tin the blue cable. Tin the XI and YI pads. Solder the naked wire to YI pad. Solder it to the pin 2 of Y sensor. Cut the wire. Solder the wire to XI pad. Solder it to the pin 2 of X sensor. Cut the wire. Solder the H pad to the main PCB. Short connect the H and C1 pad. The power layout of the 2 sensors is opposite to the main PCB, so the direction of movement of the joystick will also be opposite. Therefore, I short connect the X and Y pads to flip the direction. I'm desoldering and preparing the left stick. There are some small parts on the PCB, but it's no problem because our heating plate is designed to avoid. I'm skipping the desoldering steps. I hope you understand why some blue tubes can be removed on this left stick, and why all the blue tubes were retained on the right stick. Insert the new stick and solder it on the PCB. Put on the calibration FPCB. Sorry, the components on the board block the FPCB from sticking to the main PCB. So I'm housing the FPCB to a free location. I named the solution off the PCB. Finally, I decided to place the FPCB here. This yellow pad is double-sided, high-temperature resistant tape. Paste the calibration FPCB. Carefully check whether there is any interference in mechanical coordination. I'm connecting with these 5 color wires. Solder the pin 1 and pin 3 of the 2 sensors. The sensors directly take power from the main PCB. Connect the V1 or V2 pad to pin 3 of the X or Y sensor to power the FPCB. Connect the GND pad to the G1 pad on the main PCB. Solder the signal pin 2 from the X sensor to XI pad. Solder the signal pin 2 from the Y sensor to YI pad. Solder the output signal XO from FPCB to the main PCB with yellow wire. Do not scratch the blue tube. Solder the output signal YO from FPCB to the main PCB. Connect the button signal from near H terminal to C1 or C2 pad of the FPCB. Check the connections and make sure no wires are missing or shorted, and then organize the cables. I finished the hardware installation. Next step is to calibrate the new sticks. Most controllers work with the Gamepad Tester web, but some won't. Please download the app Joystick Tester by John Punch or other testing tools. Fully tilt the joystick at the largest angle and then plug in the USB cable. This is setting mode A. The dot is jumping at 4 poles. Now rotate the stick 3 or 4 circles at the max angle. Press the button to save the data, and then release the thumbstick cap. Do not touch it when it's reading the physical center. Unplug the USB cable to power off the controller. Power on again to see how it works. The setting mode initializes all the data. The calibration FPCB now outputs standard signal to the main PCB. If your controller comes with calibration app or tools, please do it right after setting mode A. Press down the button and do not release it, and then power on the controller. This is setting mode B. It shows the center of the stick. Reset it by pushing the stick up or down, left or right. Press the button to confirm the new center point. The dot jumps to the first pole. Push inward to shrink the range. Set the value to 1.0 and press down the button to save the data. It jumps to the second pole. Repeat the steps for all the 4 poles. Unplug the USB cable. When you see the dot keep still at the center, that's it. We finished the setting. Check the track of clockwise and counterclockwise rotation. See if it reaches the circle everywhere. Check if the center is seriously at the center. Check the 4 poles to see if they reach the circle. Check how it works at 45 degrees. You can go to the setting mode B again, add more steps after 1.0, or remove some steps on any pole to customize the outer range. The range that can be finely tuned will be helpful for some games. Plus, the accurate center setting. A new controller with Hall or TMR stick is born.